So now I'm going to need someone to remind me to start the recorder again after break, because I will pause it, and I almost forgot that. All right, so we are going to graph, given a graph, we're going to graph its transformation, vertical, horizontal shifts, vertical, horizontal compressions or stretches, and reflections. Then if I give you a parent graph of a quadratic function or square root or cubic, etc., then you're going to transform it. Okay? So we are not going to investigate because you already did this last year. So let's look at this. Does anybody remember what the number being multiplied by the function does? It stretches it vertically or compresses it vertically. Okay? This A is going to be all vertical. Guess what this B does being multiplied? A multiplied is a vertical stretch or compression. B vertical is a what? Horizontal stretch or compression. Now, do you see everything that's written here that's already typed? That's online for you to download. So all you'd have to do is fill in what I'm going to fill in. Does anybody remember what C does? These are the easy ones. It shifts it left or right. And this is the weird one because it does it opposite. D, on the other hand, is up or down. So anything that is outside of the function is vertical. Anything in that is attached to X is going to be horizontal. All right, so let's talk about the role of A. Notice it says absolute value of A is greater than 1. When we say absolute value of A is greater than 1, what we're saying essentially is ignore the sign. All right, just ignore whether it's positive or negative. If it's bigger than 1, then you have a vertical stretch. And that means the Y values are multiplied by A. Kind of nice to be able to teach from the back of the room. Oh, I lost it. There we go. Now, this is saying if the absolute value of A, again, ignoring the sign of A, if it's between 0 or 1, then you're going to have a vertical compression. That means it gets... Vertical stretch means it moves closer to the y-axis. Vertical compression means it moves away from the y-axis. And again, this piece right here, it's A. Oh, darn. I wonder if I do this. Will it let me? Yeah. Okay. So if we take this part. Oh, darn. So if we take this right here. Oh, I don't want that H. Try it again. This works for A, period. Any questions on the role of A? All right, now, what happens when A is negative? Less than 0. When you see less than 0, this is preparation for next year because you're going to be working with this a lot. This means negative. When A is negative, what happens? It's a flip. Over which axis? That's composition. Reflection over x-axis. Okay. Be back at 11:10:50. All right, moving down. We've got, so what if I have y is equal to 2x squared plus 3? What is this 2 doing to the graph? Is there reflection? Is there reflection? No. I heard a stretch. What kind of stretch? Vertical stretch by a factor of 2. That's what you're going to say to me on the test. If I have y equals 1/3 square root of x plus 7, what is the 1/3 doing? No, negative. Let's make it negative. Vertical. Okay, there's a reflection over which axis? X-axis, and there's a vertical compression by a factor of 1/3. All right. Now, the role of B is going to be very similar to the role of A. Where A was vertical stretch and compression, B is going to be horizontal stretch, horizontal compression, and reflection, not over x-axis, but the y-axis. Now, whenever you are close to x, things are weird. All right? So what does C, does this move to the left or does this move to the right? Does this move to the left or does that move to the right? So you had to do opposite, didn't you? You had to do the inverse. You with me? The inverse of subtraction is addition, etc. Well, when we're multiplying, you're going to be doing the inverse also. So rather than classifying B so that the thinking process is the same as this, you are first going to do what to B? Take the what? Reciprocal of B. If the reciprocal of B is greater than 1, then you've got a horizontal compression. If the reciprocal of B, ignoring sign, that's the whole purpose of the absolute values, between 0 and 1, oh, just kidding. I just taught you wrong. Nobody said a word. It's going to be a horizontal stretch. That means it gets closer to it's a horizontal x-axis. Reciprocal of B between 0 and 1 is going to be a horizontal compression, meaning it gets farther away from the x-axis. And in this case, you will multiply what variable? X values by the reciprocal of B. It's all about the reciprocal. Oh, I'm running out of room. Okay, so while you write that, I'm going to drag this up. And what does less than 0 mean? Negative. So when B is negative, what do we have? Reflection over the y-axis. And I need to make another, I'm going to zoom to the top for a minute. I want you to look at this. B is what? Factored, isn't it? This is in factored form. You cannot analyze a transformation if it's in the form of bx minus bc. That is not factored form. You must put it in factored form to identify the correct b and the correct c. Are you with me? Highlight it, factored form. B, it must be factored form. All right, so let's see. We're going to say, Tegan, what does 7 do to my graph? What kind? Vertical stretch, and you tell me by a factor of 7. All right, what does the 2 do to this, Shayna? Okay, this is B, but we're not going to look at 2. We're going to look at what? The reciprocal of B. This is what we classify. So what does it do? Compression. Okay, is 1/2. I tried to make this so that you could think the same way. Is 1/2 between 0 and 1? You see? And if A had been 1/2, would 1/2 be between 0 and 1? Do you see how I've tried to make them so you can think this one way? But in order to think one way, what do you have to do to be? The reciprocal. Okay, so let's do another one. Suppose I have g of x equals 5/4 f of, f of, how about 3/2 x? Negative 3/2. All right. So what does the 5/4 do, Kyle? I tried to trick you. How did I try to trick you?
Well, he tried to make it a fraction, so we would think it would be more in between 0 and 1.
Yeah, I did, and he didn't fall for it, did he? Okay, this is a vertical stretch because 5/4 is bigger than 1 by a factor of 5/4. All right, tell me one thing happening here, Bo. Tell me one thing that's going on here. Okay, so what does that mean? Right. And when b is less than 0, what happens? Yes, this graph has been reflected over the y-axis. Okay, so what does the 3/2 tell us? Oh, let's go with Jake. What does the 3/2 do? Okay, so he remembered to think 2/3, right? That's the reciprocal. 2/3 is less than 1, so it is a horizontal compression by a factor of 2/3. Any questions there? All right. Now the role of C, you all know. What does C do? Horizontal shift, opposite as it appears, correct? Opposite as it appears. Oh, and I didn't write any functions. All right, so suppose we have k of x equals negative 1/3 f of 3 times x minus 2 plus 4. All right, Kirsten, what does a negative do? Okay, we're out here. Perfect. Reflection over the x-axis. Lexi, what does a 1/3 do? Okay, that's the negative part. What about the 1/3 part? What kind? Vertical compression by a factor of 1/3. Okay. Mikhail, what does a 3 do? Excellent. What is this 2 going to do, Ashley? 2 to the right. All right. So now what is the role of D? This is a vertical what? Shift by a factor of, no, shift by what? Shift. What do we make that? D units. All right, and it's going to be as it appears. As it appears. So Rachel, what's happening? What does this plus 4 do? Up 4, exactly. So I think what I've done on your, because the textbook didn't do what I wanted it to do. So sometimes I make up my own directions. So if I look at this correctly, I need pre-calc. That is not pre-calc. Oh my. What did I do? I didn't print the pre-calc syllabus. So I can't look at it. Let's look it up. Oh, here. Oh, good. Okay, for pre-calculus, oh, I didn't ask you for that. All right, so we're going to transform functions. All right, so I didn't ask you to describe. I will probably ask you to describe on a test. That's pretty easy, don't you think? Pretty quick. Give you one of these functions and you just tell me everything about it. So tonight what you're going to be doing is, describe. Here we go. All right, so let's start with, we're going to start with Trey. Trey, tell me what's going on.
That is a vertical down by a factor of 4.
Yeah, down 4. Correct. Noah. This is notes. This is not homework. All right, so let's go to Marvel. What is going on here? Okay, there's two options. We can either be multiplying or we can be adding and subtracting. Okay? Multiplying has to do with stretches and compressions. Add and subtraction has to do with shifts. So the fact that you see +3, it's going to be a shift. The question is it vertical or is it horizontal? Is it being added directly to x or is it being added outside of x? See, this is outside of x right here. What, was it Trey that did this? See, that is outside. It's not inside with x. It's outside. That was a vertical shift down 4. Whereas it's going to be a horizontal shift 3. Which direction, though? Be careful. These the one inside ones are tricky. Is it right 3 or left 3? This is going to be opposite. Whenever you're next to x, it's going to, like the inverse operation for addition is subtraction. So this is going to move left. Okay, if it were a horizontal stretch or compression, you've got to do the reciprocal in order to classify it. So when it's outside, it's as it appears. When it's inside, it will be opposite. Okay, so let's go to Chelsea. Chelsea, what does this do? Excellent. All right, so let's do Connor. Connor, what is this going to do?
It's a vertical stretch by factor 2.
Excellent. All right, what is this going to do, David? Okay, flip means it's negative. It's inside and it's multiply. Whenever we're multiplying, it's going to be a stretch or compression. The question is it vertical or is it horizontal? It is horizontal, but it's a horizontal stretch or compression. Be careful. These are it looks like a compression, but we've got to do the reciprocal, so it is a horizontal stretch by a factor of 3. All right. This gets more interesting. See, this, to me, this is fun. And the book isn't very much fun. All right, we're going to go to Allie. Allie, do you want to classify the 5/2 or the 6? Okay, what is that doing?
That is,
Okay, why do you say it's a compression? It's a vertical stretch by a factor of? By a factor of 5/2, the full fraction. I'm looking at our homeroom schedule. This is 4/5, right? Oh, 11:31. Okay, I still got a lot of time. I saw 12:01. I thought, wow, we get to go be in here a really long time. All right, Chase, you have to do the 6 because Allie took the 5 halves. Okay, so what is the 6 doing? Yes, remember, it's inside with X, so you have to do it opposite, Matt.
And how would you word the shift?
Oh, just it moves 6 units left,
Okay.
moves 6 units right. In this case, Chase said 6 units right. All right, Christina, what do you want to do on this one? Do you want the negative, the 1, or the 6? Okay, what is this doing? Okay, so when we're at 1, we're not going to have a stretch or compression. But we do have something going on here. It's negative. So what's a negative doing? Good, over the x-axis. Natalia, you want to deal with the 1 or the 6? Okay, what's happening? Excellent. All right, on this one, we only have one choice, Tegan. You're dealing with the 6. Perfect. Did you do this last year in Algebra 2? A little bit? Okay, we're going to be doing a lot. All right, so let's go to Gabby. Which one do you want to do on this one? The negative, the 3, the 4, or the 5? Okay, what is happening? Excellent. All right, so now we're going to go to Rachel. Rachel, which one do you want to do? The negative, the 3, or the 4? Okay, what is 4 doing? Okay, good. Shifts to the right 4. All right, so we're going to go to Jack. Jack, do you want the negative or the 3? Okay, what is the negative doing? Reflection over the x-axis. And then, is there anybody I haven't called on? I'm trying to hit everybody. Noah, what is the 3 doing?
The 3 is a vertical stretch.
Excellent. All right, so if you understand what's going on, now we're going to start to graph, I hope. All right, so here we go. When you're given a graph, you're going to graph its transformations. Okay, you will do, first and foremost, all compressions stretches first. Actually, 1, 2, it doesn't really matter what order you do, but the big deal is all shifts are last. All shifts are last. Did you hear me? If you do shifts first, the whole thing's going to be wrong. On order of operation, who comes first? Multiply, divide, or add and subtract? Multiply, divide. And what do stretches and compressions involve? Multiplication. So those get done first. What do shifts involve? Add and subtract. So that comes second. Does that make sense? Okay. So this is your given graph. I think for what we're doing today, I don't think we're going to go into the functions today. I think we're going to stop here today. You will be given a graph, and then you're going to be given a function, and they're going to ask you to transform it. And I want to see the transformation. That means you either get out colored pencils, and I see different colored dots, or you use different symbols like X's and circles and triangles and squares. But I need to see it. All right, so let's look at this. This is my first one. So what I'm going to do is you will graph the parent function first. This is considered the parent. Why don't I just make this an infinite cloner? Does that work? No, it didn't work. All right. So I graphed the graph. You with me? So now what is this function telling me to do? Let's go to, let me see if I can do it without looking at the seating chart. Connor. What does this tell us to do? Right here. This is my f of x. My g of x function is f of x what? So what do I have to do to every point on here? Right. So I'm going to pick the key points. This is a key point. I'm going to move that up 1. This point goes 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 up 1. What does my new graph look like? And I want you to highlight your new graphs, so you'll know what the final one is. How's that? Was that bad? You need graph paper, I hate to tell you. But it's IB, so you got a couple days to get it. Done. And I'll even model well. See, yes, did I do it wrong? Yes. These are your notes. It's up to you. These are notes. Noah, was that your question?
Yeah, for each transformation, do you want us to draw the graph or just on the file?
No. I want the parent, and then I want all the transformations. And we'll get more interesting. This is not very interesting yet. Okay? So we're going to get this. See, this is the beauty of a smart board. Now, if you had a tablet, you probably could do this too, couldn't you? Last time I taught IB, I had kids with a tablet. It was so cool. All right, so Kirsten, what is this telling me to do? Okay, we're inside the parentheses attached to X. You see the difference between the two, because this is important. You see how the 1 is outside the parenthesis and the 3 is inside? So when you're outside the function, it's vertical. When you're inside, you're going to be yes. But which direction? Yes. So this point, notice I've already graphed my parent. 1, 2, 3. There's that point. 1, 2, 3. We've got 1, 2, 3. I guess I could have done that one. 1, 2, 3. But how many points determine a line? Geometry students? 2. So did I have to do 3 on that one? So there we go on our. Did I mess it up? Oh, there it is. Thank you. Gosh, I could not see that. All right. So there's my final answer. Not bad? Okay, let's have more fun. I should have copied, and then I could have pasted. So let me copy paste now. All right, same function. Did I get more than one? I did. We'll put that down there for later. All right, so we have several things going on. Marvel, tell me one thing going on. So we're going to reflect over x-axis. All right. What's the other thing that's going on, Noah? Okay, so we're going to go down 4. Now the big question is, can you do it in any order you want? No. Rachel, what goes first? Reflect first. All right. So when you reflect something that's on the x-axis over the x-axis, do you agree that those points do not move? Okay, so this one that was 3 down is now 3 up. These two that were 3 up are now 3 down. All right. That's first lunch. I was ready to cry. All right. So here we go. Now, do you have to do these intermediate drawings? No, but I have to see the points. There's a reflection. Now, to this dotted graph, what am I supposed to do now? Chelsea? Oh, I got a problem. I don't have enough. What is one to do? Well, I think what I will do. Oh, that's a whole lot bigger. All right, this might not line up. You know what? I did that on Sketchpad. Do those look about the same size? Oh. Not quite, huh? Make it a little bit bigger. All right, do you think we're good now? No? Oh, that's pretty close. Except now we can't see what we just did. All right, so as soon as I bring this one to the front, we'll be good to go. This is the beauty about having graph paper, not a short graph. Order. Bring to front. Well. Oh. All right, hold on. Order, I'm going to send it to the back. All right, it's these pieces. It's not going to let me do it. All right. Anyway, we're going to move each one of these down how many? 1, 2, 3, 4. We've got this one, 1, 2, 3, 4. We've got this one that's about here, 1, 2, 3, 4. We've got this one, 1, 2, 3, 4. And if this is here, 1, 2, 3, something's not right. Oh, I haven't. Did I what?
Oh, yeah, you're not the one to the on the very right.
You have to go all the way up.
Is the first sheet.
1, 2, 3. Did I do all of them wrong? All right, let's see. This is good, yes? And this is good. Ooh, sort of. I'll fix it. And that goes up to there. Okay, so now am I good?
Yes.
All right, if I move that up, try to make that straighter. Am I good now? All right. See, I didn't know where my infinite graph paper was when I did this. All right, and do I have another function here? Oh, I do. Look at that. Okay, so let's look to see what we do when we have to, oh dear. This is a stretch. All right, so I'm going to move this up here for the moment. And I'm going to get out my big graph paper so that we can see this. It's going to be a little bit confusing. And where do I find my graph paper? I want medium. Do you see medium yet? All right. Now we're in business. You ready? All right, I'm going to move this down a little bit. All right, I need axes. So we'll let's just see how it grows. Don't you wish you had graph paper that grew? All right, so now I'm going to attempt to draw the original graph. And so that's 1, 2, 3, 4, up 3. So I think what we're going to do is we're going to go over 4, then up 3 here, and over 2. Okay, and then we're going to go down through the origin, down to 3, and then up where? Here or here? 1, 2, 3. Okay. So we're going to go over 3. Are you good? Are we good? All right, so now what does this tell us? This is a vertical what? Okay, vertical stretch by a factor of what? What does that mean? Remember, on your notes I said we multiply the what? The y values. This is 0. What's 0 times 2? 0. This is 3 high. What's 3 times 2? So we're at 6. This is 3. What's 3 times 2? 6. This is negative 3. What's negative 3 times 2? So we have to go down to negative 6. What's 0 times 2? Yeah, 0. So our new graph, literally, do you see the stretch? Okay. And is it as closer to the y-axis than it would have been? Do you see how this point, I mean, that's further away than this up here? All right, so we're going to highlight it so you know what I did. Is that hard? Okay. Oh, sorry. All right. Ooh, what are we going to do this time? Yeah, this is going to be the fun one. What are we going to do? Sorry. What does this do? Horizontal. Be careful. Think.
Oh, yeah.
Compression by a factor of 1/2. Because what do we have to do on these?
Reciprocal.
Reciprocal. All right. So here are my axes. Let's see if I can remember how to do this. We were what? Over 4. 1, 2, 3, 4. Then we go up to 3, and then we go over 2. Then we go through the origin down to 3. Then we go over to 3. Is that good? Okay. So What do we multiply this time? By a what? 1/2. What's 0 times a half? Now, what is 3 times a half? So that means I go up 1 and 1/2. What is 3 times a half? So I go up 1 and 1/2. What is negative 3 times a half? So negative 1.5. And what is 0 times a half? Do you see how this got closer to the x-axis? Compression, horizontal compression, it gets closer to the axis. Don't you think this homework is going to be fun? Well, but you know what? You're going to graph the same thing.
Yeah.
You know, your parent graph will remain the same a couple times. I was kind. I was not mean. Now, to me, this is the problem I would assign all the time. You'll understand when I say the book was wimpy. Okay? If it had been me, this is what we would have done on every problem. So, can someone tell me something that's going on here while I get my parent graph going? Yes, Jake. No, Trey.
It's flipping over the x-axis.
It is flipping over the x-axis. Who else? Shayna? We're going to go, wait a minute. Okay, but you were correct in the vertical. Yes, so we're going to do a vertical downwards thingy. All right, Chelsea. We're going to go right 2. Okay, what's the half doing? Vertical compression by 1/2. So, what are we going to do first? So, you know, it's kind of helpful to write this out. We know that we're going to reflect, right, over x axis. We know we're going to do a horizontal compression factor of 1/2. We know we're going to go, you said, right 2 and down 4. Wouldn't those be easy test questions if you just described it? I like those. Okay, so what do we want? Again, reflections and compressions, it does not matter. Who goes first? What do you want to do first? Okay, so when we reflect, that doesn't change, that doesn't change, that doesn't change. But these come down here, agreed? And this goes up. Connor? No, Matt.
You put horizontal compression. Wouldn't it be a vertical compression?
Oh. Good job. Not another person said a word. Okay, you guys speak up, guys. All right, so are my green dots set? So I'm going to check that off my list. Now what do we have to do next? No choice. The compression. Who gets multiplied by 1/2? Oh, we got to redo this. I did this one all wrong. Because what did I multiply? Yes, who? And Chase, you just let me go through and do that. Chase. Oh darn it. Hey, you are here too. Should have seen it. Did anybody else see that? No, that I did it wrong? Look at those fly. Okay, so let's look at the x's. The x's get multiplied by 1/2. This x is 4. So it becomes a 2, negative 2. This x is 1, 2, 3. What's 3 times 1/2? 1 and 1/2 horizontally. This is 1, 1/2, correct? So this is 1, 1/2. This is 3, 1.5. Now that is a horizontal compression. If you were to take your hands and you were to put it on the original graph and you were to push your hands together, does it make sense that it would shrink it like this? You see it? Okay. So please make a notation. I did that wrong. All right, so now we're going to do a vertical compression by a factor of 1/2. So who gets multiplied? The y's. Now I'm multiplying greens, okay? 0 times 1/2? 0. What is 3 times 1/2? 1.5. What is 3 times 1/2? Negative 3 times 1/2? Negative 1.5. What's 3 times a half? 1.5. And what is 0 times a half? Okay, so now we did purple, correct? Or whatever you want to call that color. All right, so now what are we going to do? Right 2. So my purples, or whatever this color is, gets moved to the right 2, to the right 2, to the right 2, to the right 2, and we're on purple, to the right 2. Am I good so far? Now what are we supposed to do? All right, so I'm on blue. 1, 2, 3, 4. We've got, I need space. Okay, now we're on the halfways. We got 1, 2, 3, 4. We've got 1, 2, 3, 4. Blue, right? 1, 2, 3. Do you see how colored pencils could be helpful? 1, 2, 3, 4. All right, see if I can do this correctly. And I can't draw a straight line if my life depended on it. Here we go. But now I can. That's been reflected. That has been compressed vertically, and that has been shifted 2 directions. All right, so it's important the order that you do it in. Oh, wow, and we are so close to lunchtime. All right, and I'm pretty certain that I did not give you any functions. I believe next section we're going to do this with functions. All right, next session, if you would please try to remind me that I did have a video to show you all. Okay, I wanted to show you a video.